Welcome to today's paper reading. Today's paper is titled, AUTOGEN STUDIO, a no-code developer tool for building and debugging multi-agent systems. This paper was published on the AR14 preprint by Victor Dibia and colleagues from Microsoft Research. The abstract introduces the concept of multi-agent systems, which involve multiple AI models and tools collaborating to solve complex, long-running tasks. Despite their effectiveness, these systems present challenges in specifying parameters and debugging. To tackle these issues, the authors present AUTOGEN STUDIO, a no-code developer tool designed for rapid prototyping, debugging, and evaluation of multi-agent workflows. AUTOGEN STUDIO is built upon the AUTOGEN framework and offers both a web interface and a Python API. It uses a declarative, JSON-based specification for representing LLM-enabled agents and features an intuitive drag-and-drop UI for workflow specification, interactive evaluation, and debugging. Additionally, it includes a gallery of reusable agent components and adheres to 4 design principles for no-code multi-agent developer tools. Generative AI models, when combined with the ability to act, function as agents capable of complex problem-solving. Recent research indicates that transitioning from fixed-agent pipelines to multi-agent setups with autonomous capabilities can enhance factuality and reasoning. This has led to the development of frameworks like AUTOGEN, Camel, and TaskWeaver. However, multi-agent systems introduce challenges such as configuring numerous parameters and debugging complex interactions. To address these, AUTOGEN STUDIO has been developed as a tool for rapidly prototyping, debugging, and evaluating multi-agent workflows. It offers profiling capabilities and a drag-and-drop interface for authoring complex workflows. AUTOGEN STUDIO is also an open-source project with a significant user base, providing a platform for research and practice in multi-agent developer tooling. Figure 1 illustrates the drag-and-drop user interface of AUTOGEN STUDIO, a tool designed for rapidly prototyping, debugging, and evaluating multi-agent workflows. The interface allows users to define and attach models, skills/tools, and memory components to agents, and subsequently, to workflows. This visual approach simplifies the process of creating complex multi-agent systems, making it accessible for developers without extensive coding experience. The limitations of generative AI models include issues such as hallucination, limited performance on reasoning tasks, and difficulties with novel out-of-distribution problems. To address these challenges, there has been a shift towards agentic implementations where models are equipped with tools to enhance their performance. Frameworks like React Explorer Reason and Act Paradigm, interleaving reasoning traces with task-specific actions. As tasks grow more complex, predefined pipelines show limited effectiveness, prompting the development of more flexible and adaptive agent architectures. Several multi-agent frameworks have been proposed, including AUTOGEN, Camel, and OS Copilot, each offering unique approaches to building and managing multi-agent systems. These frameworks are built around core concepts such as the generative AI model, skills or tools, memory, individual agents, and workflows, which define how agents interact to address tasks. AUTOGEN STUDIO is designed with 3 core objectives to enhance the multi-agent developer experience. Firstly, it focuses on rapid prototyping, providing a playground where developers can quickly specify agent configurations and compose these agents into effective multi-agent workflows. Secondly, it offers developer tooling designed to help developers understand and debug agent behaviors, facilitating the improvement of multi-agent systems. Lastly, it presents a gallery of reusable, shareable templates to bootstrap agent workflow creation. This approach aims to establish shared standards and best practices for multi-agent system development, promoting wider adoption and implementation of multi-agent solutions. The system design of AUTOGEN STUDIO is divided into 2 main components, the front-end user interface and the back-end API. The front-end UI is built using React and features 3 main views: the build view for creating multi-agent workflows, the playground view for interactive task execution and debugging, and the gallery view for sharing and reusing agent templates. The UI supports a drag-and-drop interaction for composing workflows. On the back end, AUTOGEN STUDIO provides a web API, a Python API, and a command line interface. The Web API, built with Fast API, includes REST endpoints for managing entities like skills, models, and workflows. The Workflow Manager class handles the execution of tasks, while the Profiler class computes metrics for debugging. Workflows can be defined declaratively, tested in situ or systematically, and exported for integration into Python applications or deployment via Docker containers. Figure 2 illustrates the comprehensive backend API and user interface of AUTOGEN Studio. The backend API is composed of web, Python, and command line interfaces, facilitating diverse interaction methods. The UI encompasses a playground, build, and gallery view, each serving distinct purposes in workflow management and component exploration. Notably, the playground view allows users to execute tasks within sessions, monitor agent actions, and analyze performance metrics through the Profiler module, enhancing the debugging and testing process. The AUTOGEN Studio package has seen significant usage since its release on GitHub, with over 200,000 installations in just 5 months. This widespread adoption has allowed for an iterative evaluation approach, leading to improvements based on more than 135 GitHub issues. User feedback highlighted several challenges, which were subsequently addressed. These included difficulties in defining and reusing components, resolved by implementing a database layer, and issues in authoring components, which were mitigated by supporting automated tool generation and integrating an IDE for editing tools. Additionally, frustrations caused by component failures during end-to-end tests were alleviated by incorporating a test button for components and workflows in the build view. In this section, the authors discuss emerging design patterns for no-code interfaces aimed at building next-generation multi-agent applications. The first pattern is Define and Compose Workflows, which allows users to create workflows by defining components and composing them through drag-and-drop actions. This approach includes visual tools to help users understand and configure parameters, as well as an integrated development environment, IDE, for authoring and testing entities. The second pattern focuses on debugging and sense-making tools, which are essential for interpreting and rationalizing the behavior of multi-agent systems, especially when dealing with issues like improperly configured models or agent instructions. Lastly, the authors highlight the need for export and deployment capabilities, enabling seamless transfer of multi-agent workflows to different platforms and environments, crucial for integrating these workflows into core applications. Figure 3 presents a visualization of GitHub issues from the AUTOGEN Studio repository, categorized into 8 clusters. Each point on the plot represents an issue, with the clustering based on an embedding of the issue text using OpenAI's Text Embedding 3 large model. The embeddings were reduced to 2 dimensions using UMAP and clustered with k-means. The user feedback encapsulated in these issues spans various aspects, from support with workflow authoring tools, such as configuring and testing models, to general installation challenges. The paper identifies 3 key future research directions. First, the development of offline evaluation tools to measure agent performance, understand their strengths and limitations, and compare different architectures. Second, understanding and quantifying the impact of multi-agent system design decisions, such as determining the optimal number and composition of agents, and the best way to distribute responsibilities. Third, optimizing multi-agent systems by dynamically generating agents based on task requirements, tuning workflow configurations for optimal performance, and adapting to changing environments and user preferences. In this paper, the authors introduced AUTOGEN Studio, a no-code developer tool designed for rapid prototyping, debugging, and evaluation of multi-agent workflows. Key features of AUTOGEN Studio include a drag-and-drop interface for composing agent workflows, interactive debugging capabilities, and a gallery of reusable agent components. Through its widespread adoption, the authors identified emerging design patterns for multi-agent developer tools, such as a define and compose approach to authoring workflows, debugging tools to understand agent behaviors, and tools to enable deployment and collaborative sharing. This tool lowers the barrier to entry for multi-agent application development, potentially accelerating innovation in the field. The authors also outline future research directions, including the development of offline evaluation tools ablation studies to quantify the impact of multi-agent systems design decisions, and methods for optimizing multi-agent systems. The purpose of AUTOGEN Studio is to facilitate rapid prototyping and testing of multi-agent workflows in a no-code environment. The goal is to responsibly advance research and practice in solving problems involving multiple agents, with a focus on contributing to human well-being. AUTOGEN Studio is committed to implementing features that ensure safe and reliable outcomes. For instance, the platform offers profiling tools to analyze and understand agent actions, thereby promoting ethical implementation. Thank you for watching.